presented by Claudia Von Pacano and Geoff Bacon, both at the University of California, Berkeley D Lab, and both instructors for Sage Campus's Introduction to Data Science for Social Scientists course. And stay tuned, by the way, for a discount for the course, which starts on May 14th. My name is Michael Todd, and I am the Community Manager of the MethodSpace website. Let me introduce you to our guests for today's webinar. Dr. Claudia Von Pacano is the Executive Director of the D Lab in Digital Humanities at the University of California, Berkeley, and is on the board of the Social Science Matrix. She has a master's degree from Stanford University in Learning, Design, and Technology, and a doctorate in Policy, Organizations, Measurement, and Evaluation from UC Berkeley. Claudia's scholarly work and service have been recognized by Phi Beta Kappa Society, the Andrew W. Mellon Foundation, the Rockefeller Brothers Foundation, and the Thomas J. Watson Foundation, among others. Geoff Bacon is a PhD student in the Language and Cognition Lab and graduate student researchers at the D Lab. His research focuses on two questions: why languages look the way they do, and how people learn to express temporal semantics. To study these, Geoff uses probabilistic models of language, including Bayesian and neural network models, and he programs in Python. As an undergrad, Geoff studied linguistics, classics, and Arabic. And if you aren't familiar yet with Berkeley's famed D Lab, it helps UC Berkeley's faculty, staff, and graduate students move forward with world-class research in data-intensive social science. Now, this one-hour webinar will be recorded and archived for future viewing, and we will be sending out a link to view it in the coming weeks to registrants. If any of you have any problems with audio or viewing mode during the webinar, please use the Q&A box on the right of your screen, and one of our helpful team members will get back to you ASAP. Now, in the next hour, I'm going to ask some questions of Claudia and Geoff about the intersection of social science and data science. Geoff will follow that with a cool demonstration of the Jupyter platform, and then we'll take questions from you, the audience, for a full half hour. Again, please use the Q&A box to ask any questions to the speakers throughout the webinar, although we'll only start answering them in the second half. And you can also leave comments there or tweet to us using the hashtag SageCampus hashtag. So keeping that in mind for the audience, let's start the conversation. Claudia and Geoff, why don't you tell us a little bit more about yourselves and the D Lab?
Hello.
Hi there.
We're so excited to be here today, as Michael, thank you so much for your kind introduction. Stated, I'm Claudia, and this is Geoff.
Hi there.
And so we're absolutely thrilled that you're all joining us today, and we're really excited also to be able to respond to specific questions that you may have about our Introduction to Data Science for Social Science course. So first of all, I want to answer the most pressing question here, which is, what is data science? Data science is the science of extracting knowledge and insights from social data, in our case. And data scientists are very well versed at parsing and analyzing large amounts of data. And then, of course, most of you are probably social scientists, and we know that social science is the study of people, society, and individuals within a society. And we all have different methodological training within our disciplines that we can contribute to the growth of data science, importantly, because I think until fairly recently, I would argue, perhaps it wasn't clear the crucial role that social scientists play in shaping data science. And so right now we're going to talk a little bit about the D Lab. We're going to talk a little bit about data science more broadly and why we want to use data science in the social sciences. And then we're also going to have this exciting opportunity to have Geoff show us an incredibly powerful tool called Jupyter Notebooks within the larger schema of the Jupyter project, which comes from UC Berkeley. We're very proud to say.
Yeah, I think you guys are really going to enjoy that. It's really the cutting edge of how data science is done in a day-to-day life for data scientists in academia, as well as data scientists in industry and government. So yeah, it's super exciting to be able to show you guys do that. And in the course as well, you know, if you take the course, you'll be exposed to just much more of it and some of the other tools that we use in the data science workflow. So we can talk a little bit about that later, though. So.
Perfect. Thanks so much. So let's start with what the motivation might be for you to learn more about data science. So of course, we know that social scientists have been working with a wide array of different types of data for more than 100 years, probably.
Mm-hmm.
But what has happened in recent times, I would say about 10 years really, is the datafication of virtually everything. You all know that every time you purchase something, every time you take a book out of the library, every time you really make any kind of transaction, it's almost always being tracked. It sounds a little scary, and it is a little scary, by some kind of data system, right? And so it's the datafication of virtually everything. And when we used to, in the past, be able to think, oh, okay, let's just think about a sample, right? Currently, the reality is that many times we could actually approach the whole population depending on what the research question is. And so that is radically changing the way that we actually use data, process data, and the way that we use statistics. So it's actually changing issues such as the p-value.
Yeah, other kinds of data that actually that Claudia is talking about in the datafication, you know, imagine your social media, your Twitter and your Facebook and your YouTube, things like that. Every time you make a comment or someone makes a comment on a online forum like that, that's data that these companies have, and that can be used to answer questions about society, which is what social science is all about. So yeah, a great example of that is one of the projects we're doing here at the UC Berkeley's D Lab, which is our online hate speech project. So we're sort of trying to tackle the problem of online hate speech, people going onto social platforms like Reddit or Twitter or Facebook, things like that, and saying, you know, really harmful things to other people, and particularly hateful things. And so obviously there's a lot of interest in these companies like Facebook and Reddit, things like that, to stop the spread of this bad content. There's also something for social scientists, again, to sort of understand that phenomenon a little bit more so that we can better counteract it, you know, more effectively, things like that.
I'm glad that Geoff brought this up, and I think it's really timely because one of the things that we cover in this course is ethics. And ethics are really being redefined because there's a lot of vulnerable populations that are being tracked, and that we are maintaining data on different vulnerable populations as well. So, you know, the previously incarcerated or undocumented. So these vulnerable populations, in the past, we have very strict rules. Institutional review boards at each of our universities are making decisions as to how we're treating those populations when we're studying phenomena regarding those populations. But currently, it's very difficult for us to really control because there's a lot of data matching that can happen. So even if a data set is de-identified, it could be re-identified by many different people because there's variables that may be in common. So ethics, more broadly speaking, just taking a step back, is something that we cover in this Introduction to Data Science course. But very specifically, just to talk about our work here at the D Lab, one of the things that we are working on and we're very proud of and excited about is hate speech, because we do believe that we have to create an environment online that is friendly and warm and safe for everyone. And it's a really fascinating project that we've taken on with the Anti-Defamation League. It's a partnership that we have with the Anti-Defamation League, but also, as Geoff was mentioning, we're forging a partnership with Google, Reddit, and other organizations that we're in conversations with. But what we've done, essentially, is take 80,000, in phase one, we took 80,000 subreddit comments, and we hand-labeled those comments, so did qualitative methods for thematic coding to make sure that the comments that we had were sorted as hate and not hate. And then once we had that data set, we used that as a learning set for machine learning, and we actually evolved a model to predict whether a comment is hate or not hate. Geoff can tell you a lot more about the machine learning aspect of this, but I will note that one of our analytic lessons that is available through Sage Campus is specifically about machine learning. And so you could get into much greater depth regarding machine learning at a later stage after you take this introductory course.
Yeah, it's a great idea to take this introductory course because it gives you the tools that you would need to take those sort of more advanced things and work on projects like this, either at an institution yourself or at work, or maybe it's a side project. Because one of the great things about data science is that it really puts these tools into everyone's hands, into your hands, and you can do it whenever you like, at work, at school, in your own time. And so this introductory course is going to give you that firm foundation of computational tools, learning Python and R, and a couple of other pieces of the
data collection.
Yeah.
But Geoff, tell us a little bit about your research.
So I'm always happy to talk about myself. My research is in the linguistics department here. I also sort of border with cognitive science. And my research is on developing methods that can extract temporal information out of text. So to give you an example, imagine you're a political scientist or a sociologist and you're studying something like, the outcry after Brexit, or maybe a particular big social movement, Occupy Wall Street, something like that. And you've got a whole bunch of newspaper articles about, these big events that are happening. Maybe there's a protest or something. And you would like to be able to study this, this event, but in a large-scale way, not just reading one newspaper article. Maybe you want to read 10,000. Because 10,000 newspaper articles cover different angles. And so what I'm working on is a sort of essentially a computer program to be able to read a newspaper article for you and extract out something like, okay, well, this event of a bill being passed in the parliament happened on this date. And then 2 days after that is when there was this protest. And then during that protest, there were 3 people that were arrested. And then 2 days after that, one of the people was acquitted and 2 people maybe went to jail or something. So just sort of structuring that information that's encoded in the natural language text in a way that then, you can get it in sort of a spreadsheet and then start doing some statistics on it, things like that. So.
Wow, so text as data. That's fantastic, and it's incredible to think about. All of a sudden, it's not a few articles that you're reviewing, but actually an entire corpora of surrounding a specific event or series of events, and therefore the power that you have, the analytic purchase that gives you is incredible.
Absolutely, and it goes back to what you were saying before, Claudia, about not just having a sample, but maybe having the whole sort of population. I mean, you can basically have every single newspaper article written about Brexit or about Occupy Wall Street, at your fingertips with these sort of tools that we're teaching you in this course.
So that's revolutionizing social science methods, as you can imagine, right? If we have so many more data points and we have so much more robust information and we can triangulate that information in different ways, then it really is changing the way that we go about practicing our disciplines. But, going back to this other issue, that there are data scientists out in different corporations and different organizations that may not have a social science background. And so I wanted to just pick up on something that Geoff said, which is another reason that it would be great for you to take this course is that it really makes you much more competitive, not only within academia, because now you have this expanded toolkit that is almost, frankly, like required knowledge. Some level of this data science toolkit is almost like required knowledge, but you can get into greater depth, and really that's a competitive edge. But importantly, we also know that para-academic alternative career paths are increasingly interesting to students, graduates, postdocs, scholars. And so as Geoff was mentioning, there's so many different opportunities out in different fields to not only be in data science, but to be a social scientist within data science, because you bring social theory and knowledge of these different methods from a social science perspective. So that would really uniquely position you to really move around in your career with much greater flexibility. But let's talk a little bit about the D Lab.
Yeah.
The D Lab is a tremendous space, if I do say so myself. I got involved with the social science D Lab or Data Lab 5 years ago when it was created. I got involved as a graduate student, and until I got involved at that year, I had never had the kind of experience, the cross-disciplinary exposure, the kind of collaboration and camaraderie, the peer-to-peer support that we developed here at the D Lab. So we created a center, a laboratory, social science and humanities center, much like many labs, scientific labs on other parts of campus, where we have faculty and postdocs and graduate students and undergrads working together on different research projects such as the hate speech project. But we also offer hundreds of workshops. We serve 6,000 scholars per year in workshops and consulting and working groups, research groups. And so we're the largest onboarding data science organization on campus. But importantly, what our motto is it's okay not to know. And it's okay not to know is about the fact that there's no question that is a dumb question. We really are about meeting your needs wherever you are. All you need is curiosity. All you need is a research question or a research direction. And we sit down with you and really explore that and resource you in order to support you. And so it's become a really vibrant, multidisciplinary community, and it's really an environment that and a service that we're really excited to bring to all of you, because we think that it's a model for how data science should be taught. Really not in the sort of bro culture where, it's like a lingo that nobody really understands except for the in-group.
Yeah, the jargon is really intimidating, and I have that feeling myself, and perhaps I can give you a little bit of background on myself. You heard before from Michael that I didn't study anything to do with computers in my undergrad. I was learning ancient Greek and Sanskrit, and
So cool.
So I know that feeling really deeply of what it's like to see these terms being used, to see people writing computer programs on their own and using statistical methods and talking about p-values, and I didn't even know what a p-value was or what a function was or any of these things. And I found that really intimidating, and so eventually, through a lot of hard work and a lot of really sympathetic friends, I managed to sort of bring myself up to where I am now, and able to use these techniques on a day-to-day basis. And now I'm just so passionate about teaching them properly, teaching them in a very friendly way, in a way in which it's okay not to know the answer already, which is why I feel like I love D-Lab so much.
Unprompted.
and so now I teach the Python courses here and the computational text analysis, along with a couple other workshops here.
And Geoff is a fantastic instructor. We get very positive feedback.
That was prompted.
And no, and it's absolutely true. It's really about changing the culture of sort of this in-group culture that exists within computer science sometimes, not to be overly critical, but that exists sometimes in this heavily computer programming kind of environment, or very sort of math-centric environment.
Male-dominated.
Male-dominated, unfortunately, but luckily not at the D Lab. And I think we really are looking forward to having students from all over the world that represent different language groups and different origins, because we have a lot of experience working with international students and students from all walks of life. I do want to make sure that we do give you a little bit more of a sense, but I think I heard Geoff wanted to say something.
Yeah, I just wanted to touch base a little bit before about, give you a little sneak peek of something in the course, and we're talking about so the idea that, that social scientists not only have something to gain from data science, but also have something really strong to offer, and that's the social theory and the grounding and the context of these questions that Claudia was discussing before. And then we've also got this idea that, you do need a little bit of knowledge in programming and a little bit of knowledge in statistics. There's this really famous picture in the data science community, and it is from about 2010, and we'll talk about it in the course. But basically, it's a Venn diagram of sort of the skills that you might need to be a data scientist. And we've got sort of the computer science-y programming stuff down here, and then we've got some statistics and machine learning over here, and they definitely overlap. And then the third one here, right at the top, is domain expertise, which in the context of most data science questions is actually social science, because
Absolutely.
most of the data science stuff that's being done, certainly outside of academia, but also in academia, they're social science questions. They're about human behavior. They're about, why it is that people do certain things. Why do they vote this way? Why do they click on this? Why do they do this? These are the bread and butter questions that social scientists have been dealing with for ages. And so it's really exciting, actually, that, if social scientists such as yourself can sort of pick up a little bit of this skills and a little bit of this skills of the kind that we're going to be teaching you in this course, it's kind of just exciting to think about what you guys can do. Yeah.
Absolutely. And so we take you through the whole process, and we consider ourselves data scientists, but this is an introductory course, and so you don't need to commit. And also, we're going to have these. You don't need to know R or Python or any programming language for the introductory course. It's a zero barrier for entry for the introductory course. Little by little, after you take the introductory course, you can choose to take R or Python or both, and then you can choose to take different analytic pieces, network analysis, geospatial analysis, machine learning, and build your portfolio of knowledge in your toolkit. But for now, don't worry about any of that, because this introductory course, what it will do is give you an orientation of the field. So what we're going to do is we're going to talk to you about what is the life cycle, the data life cycle. So we're going to explain how you do, data processing, pre-processing. We're going to look at different data acquisition methods, some traditional and some less traditional. For example, in the next phase of the hate speech project that we're working on, we're really excited because we're going to be doing some crowdsourcing of our data set. And so we're going to actually use a large group of folks out in the world through Mechanical Turk to actually label a larger data set. So that's something we will cover in this course, and we'll talk about survey development, survey instrumentation, and new innovations in that area, applications such as Qualtrics, which is such an amazingly powerful tool that we really like. And so we're going to give you an orientation of different tools and different methods throughout the life cycle of data. And we're going to talk a little bit about data analysis, but we're going to delve more deeply into different analytic methods in the subsequent courses, and preferably after you've taken either the bite-size R or bite-size Python courses. But also don't feel intimidated by that. Like, I myself am more of like tweaking code, and I'm not going to write prolific code like Geoff over here instantaneously. I'm really about using existing resources and shifting them and creating them for my own purposes. But there's a wide array of different so one of the things that I want to emphasize is that probably the most important thing you'll learn in this course is how to learn in data science online. There's so many different communities, so many different ways to resource yourself, but you wouldn't know that they're there unless you're introduced and welcomed. And so we're going to welcome you to this community of folks that are really passionate about different topics and that are actually going to answer your questions at like 2 in the morning when you're stuck in some way. So there's a lot of different communities. We're going to introduce you to GitHub, which is really at the center of a lot of these communities. And of course, in just a couple of minutes, we're so excited to introduce you to Jupyter Notebooks. And again, don't be intimidated by that. It's just an HTML page. It's markup language that explains what the code is, and then some executable code in different little boxes. And so it's really like a scaffold for you to learn iteratively and to optimize the use of all these free Jupyter notebooks that are available in the world that are really like ways for you to learn and for us to support you. So I'm excited to see that demo that Geoff is going to take us through.
Yeah, it is really exciting, Claudia, isn't it? And another thing that kind of comes with the sort of the datification and the uptake of data science is the fact that, as Claudia mentioned, so GitHub is this website where people can sort of post their code and make it available to anyone, is exactly that scientists, social scientists, are making their analyses available, publicly available on GitHub, and you can just go on GitHub and look at someone's Jupyter notebook and read the text in there and see the code. And so the core idea there is that everything you do is reproducible. Exactly. Is that if somebody writes a paper and publishes their code with it, you can go and check their facts and make sure that that what they said is what they actually did. And maybe you have a better idea of how to improve it or tweak it or something like that.
Yeah, and I think that it makes your research much more collaborative because you can work with the research team in a way that's really transparent. So each analytic and interpretive step is being documented. And so then that gives you a fair, well, that's a very loud reminder that we should move on to the Jupyter Notebook. Yeah.
But so you're just saying that the reproducibility and collaboration are kind of core aspects of like the data science community, right?
Absolutely, yes, and it really makes it highly collaborative.
And so, so this Jupyter project is something that we're going to tell you all about in the course, and I'll show you in a sec. But just to sort of step back a bit, Fernando Perez, who's now a faculty member here at UC Berkeley, as a graduate student, he wanted an environment to write his code that was more interactive and more collaborative than what he was previously using, what the status quo was beforehand. And so to sort of a brief introduction in a sentence summary of Jupyter Notebooks, he invented these Jupyter Notebooks, is that they make writing code much more user-friendly and much more easy to explain what it is that you're doing. And so now it's blown up, this Jupyter project has blown up into a huge project worldwide. There are tens of people who are paid to work on it, and hundreds of people around the world who work on it for free, who volunteer their time to make this software better. And now it's just basically an industry standard of everyone using Jupyter Notebooks. So it's really important to sort of know at least what they are and how they work.
I'll only add a couple things. One is that we have an interview with Fernando featured in our materials, which is really exciting and fun. He's an incredibly inspiring person, and I think you'll really enjoy hearing his thoughts about what data science is and what social scientists have to contribute to data science. But also, Geoff was very generous, but I'm sure Fernando would say that he was one of a couple contributors in the founding of Jupyter Project. He's a very humble person, and so I'll make sure to add that. But absolutely.
Excellent. Great. Thanks, Claudia. So what I can do now is switch over on this screen to show you all about Jupyter Notebooks. So let me know if you can still see my face on the screen. And Michael, perhaps you can tell me if you can't see my screen right now.
Geoff, I can see your screen. I can't see your face at this point, and then the actual box with the code in it is relatively small.
Excellent. Okay, thanks for that. So let's make this a little bit bigger. And how does that look there?
It could stand to be a little bit bigger. There we go.
Excellent. So, so we're just going to focus on the screen at the moment, and so I didn't actually want to show you too much of a close-up of my face. And so, so what I want to show you is an introduction to Jupyter Notebooks. But before we get there, I'd like to explain, to sort of motivate why they are so game-changing. And I want to show you different ways of interacting with your computer, different ways of writing code on your computer. And in short, what Fernando Perez and his co-founders of the Jupyter project sort of did was make this experience a lot better. So I'll show you what people originally sort of used to do when they were social scientists or any kind of scientist wanting to write code. And I'll use the example of Python code, but everything's the same if you're talking about learning R or maybe MATLAB or Octave or C or C++ or Java. It's all sort of the same. It's just writing text instructions into your computer. And so this is I'm going to show you 3 ways of how to interact with the Python language. And I'm going to start by writing Python to my computer like this. And when I run that starts a Python session. And so now I can write Python code to my heart's content, and my computer will execute all this code. Now don't worry if you've never seen Python code before, if you've never seen any code before. It's just, that's not the important details here. It's just text that I'm writing to my computer. And it actually at the moment looks a lot like high school algebra. So I say x equals 1, and that gives me a variable called x that has the value 1 in it, and y equals, let's make y equal 2 to be a little bit different. And now I can say, okay, show me what x plus y is. And I say that print x plus y in Python, and it tells me that y equals 3. And so you can imagine that I can continue on sort of writing my code in this way, but as I'm sure you can agree, it's not a very nice thing to look at on your screen. You've just got a big black and white box and you're typing text into your computer, and it doesn't really look very nice and to be staring at all day. Another thing is that if I was to stop working right now, I would quit Python like this, and I've lost all of the information and the data that I had before. So if I had just proven some really important result and I had you know, a great graph to show someone, it's all sort of locked into that previous Python session before that I just quit. And so now I don't have that at all. So that's not great. And so there's another thing that people do to get around this. And this is the second way that people normally use or used to use Python and other programming languages. They open up a file on their computer, and I'll make this one a bit bigger too. And this one I've called myscript.py. So Python files always end with the extension .py. And so again, I don't want people to sort of worry about what this code is, but you know, it's Python code. But what I can show you is it's looking just the same as before. I've got x equals 1, y equals 2, and now I'm going to print something very similar, and then I'm going to do something else as well. So if I save that file, and now you can see it's sort of, it's on my desktop, and now I write Python 3 myscript like this. What that's going to do is open up a Python session for me, run all of these commands, and just show me the result. So let's do that now, and time to do something. But eventually it's going to do the same as before. Here's the x plus 3 that you might see from before, and then here's a little scatter plot that I made in this code. So this is an improvement because now I have all my code sort of saved here, and if I wanted to, I could add little instructions to myself. We call them comments in programming languages. So I'm going to start this comment with a hashtag, and now the computer is not going to think this is Python code. So this is just a reminder to myself about what my code does. So maybe I might say here, make the scatter plot. And so I know when I go and, and when I'm looking back at this file again, that I can, know where it is that the scatter plot is going to, this is the code that generates the scatter plot. So again, this is an improvement because I've sort of saved the code that I'm talking about, but it's just got a little bit of color now, but it's not much more than what I had before using this sort of black and white screen here. So Jupyter Notebooks fundamentally sort of changed this experience. So let me sort of show you what the Jupyter Notebook system looks like. I'm going to start it up here on my computer, and what it's going to do is open up a screen in a web browser for me. Just like this. Now, importantly to note, this is displayed every time you work with a Jupyter Notebook. This is displayed in my web browser, but it's not necessarily having anything to do with the internet. Jupyter Notebooks make use of the fact that web browsers are really good at visualizing things. So they have really good codes like Google Chrome or Safari or Internet Explorer are really good at visualizing graphics, and colors and things like that. And so rather than having to write their own software in the Jupyter project to be just as good at showing colors and graphics and stuff, they're kind of just piggybacking a little bit on the graphics that are inherent in a web browser. So it's opening up in my web browser, but this is nothing to do with the internet yet. And it's showing me all my files on my computer. So let's go and have a look at a Jupyter Notebook. Perhaps we can, let's start a new one actually. So I'll go here and I'll click New, and then I'll say, I want my Jupyter Notebook to be in Python. But as you saw, I could also just as well choose it to be R or anything else actually. And here's your first Jupyter Notebook. It's not terribly exciting at the moment, but here I can write x equals 1, y equals 2, and then print x plus y. And if I run that, it's just Python code, just as the same as before. So I can give it a file name, maybe my first notebook. And for historical reasons, all the Python notebooks have this .ipynb, which stands for IPython notebook. We tell you a little bit about that in the course. But here it is. I can write my code. But more than that, I can write sort of little, here is the title for my notebook. And now I get this really nice formatted text. And so I can say something like, in this notebook, I am going to explore my data set. And then perhaps, see how this text formats really nicely. And then perhaps I want to say something like, the 3 things I want to do are, and now I can have a list. Load my data set, explore my data set, have results to impress my advisor. And so you see how I just sort of, I had these just like a hyphen there, but they turned into a fully formed like a list. And the idea is that I can, in this one file, in this one Jupyter Notebook file, I can mix both my code and sort of nicely formatted instructions to myself or to somebody else that document my code and tell me what it is that I'm doing. So perhaps this next one here will be this next cell. Each one of these little boxes here is called a cell, is where I calculate my main result. And then I'll do z equals x plus y times 2. Print z. And so this is perhaps my main result. And now if I was to look at this in 6 months' time, I can remember that I can read the documentation I wrote to myself and read the code at the same time, and also like, know this is where the main result is, and then and this is the code that generated my result. So in terms of the reproducibility that we were talking about before, that Claudia and I were talking about, if you just sort of put this on the web, people can, when you publish a paper, people can check what you said was correct and check what you did was right, and even just copy this notebook and then start modifying it themselves. And so so this is what a notebook looks like. It's not kind of a great notebook, so I'd like to show you one that I've been sort of using myself. Maybe I've got here something that SEMREP, that might be good. So I'll show you some of these data sets that I've been working with, and maybe the Quebec one will be nice, and we can look at Explore. So here's my notebook that I'm using in my dissertation work, and it's loading up at the moment. But now I can see exactly what it is that this notebook is about. I've written that I want to explore Quebec a little bit. Quebec is a particular method that I'm using in my dissertation, and I've got some text here explaining what's going on. Here's a bunch of Python code, and if I run that, it'll take a little time to run, but it'll do some stuff. And here's some more code with some headings of what's going on. Here's some more code and some output. But now I want to sort of, here's the bit where I do some exploration. And I've got a question that I'm asking myself, what dimensions and features are aligned? So that's a question that makes sense in my field. And again, don't worry about, the code that is happening here. That's not something I want to focus on, or certainly not as well like the content. That's pretty specific to my field. But you can see that I'm writing the description of what's going on, and then the code here, and then I see the output at the same time. So it's these three different things that are all tied together in the Jupyter Notebook system. And then here's where I can show you nice like graphics. So this is the graphics that I was talking about before, about being sort of really pretty, I guess, and that's like more fun to look at. And yeah, so each time I have sort of a question, I have some text, and then here's the code that generated it, and here's the result. So I hope that what you're sort of seeing is the end result of a Jupyter Notebook is that you can tell a story with your analysis, that your code and your results and the text describing it all sort of contribute to a narrative about your analysis, about what it is that you're doing. And so it's all just one big thing, and you can put this online or send it to your colleagues or friends or advisor, and they can know exactly what it is that you've been doing. And so we're going to be using Jupyter Notebooks exclusively in the course as our sort of programming environment. And they'll also show up in your web browser. These ones actually, when you do it in the course, they will be happening over the internet. So you won't have to have any software installed on your machine other than having access to the internet and having a web browser yourself. And you can just sort of click a button. It'll take you to exactly a notebook like this, and you can go ahead and complete all the practical programming exercises that we have in this in the course. And so, yeah, it's really exciting to be using this cutting edge sort of the industry standard of data science. And it's even more exciting that we sort of go and get lunch and walk past Fernando Perez and his team themselves. And that's really cool. We can ask them questions about how this all works and things like that. And so I hope that what this brief introduction to Jupyter Notebooks has sort of shown you is how useful they can be to tell a story with your code, tell a story with your analysis, that ultimately makes the work that you do more reproducible and more collaborative. So that's the end of my brief introduction to the Jupyter Notebook, and so I can switch back now to the screen, and we can perhaps field some questions from the audience.
Yeah, I want to thank you so much, Geoff, and thank you, Claudia. And we will turn to questions from the audience, which, by the way, is truly global today. So whether you are in Louisville or Lusaka, please use the Q&A box on the right of your screen to ask questions. You can also use our webinar hashtag, which is #SageCampus, to send questions via Twitter. So you were just talking about state-of-the-art, so our first question is going to, from Diane, is questioning other software packages. So there's a lot of automated machine learning software packages out there, and this Jupyter seems to be kind of similar to SAS or SPSS or other things. So I'm just wondering if you can talk about other packages, and if there is similarity, why Jupyter?
Yeah, that is a great question. So in a sense, they are similar. So SAS or Stata or maybe even RStudio are environments that that people have been using perhaps in the social sciences for quite some time. And we actually teach some of them at the D Lab here because we know that so many people use them. I think the major benefit over these sorts of environments, so the SAS or Stata or RStudio, the major benefit that Jupyter Notebooks have over those environments is that these are, Jupyter Notebooks are language independent. So by that I mean, it doesn't matter if you're working in Python, I showed you Python before, or it doesn't matter if you're working in R, you can always use Jupyter Notebooks. You saw that button that I had before where I chose whether it was Python or R, and there were other choices I could make like Java or C or things like that. And so regardless of what programming language I'm working with, I can always use this consistent interface. Versus with these ones, I'm stuck to using exactly what it is that is first that they're written in. And so, you know, being able to switch between Python and R, they're both open source, they're both free, they're both, you want to talk a little bit about how they're kind of like, yeah.
I did want to just reinforce what Geoff is saying in that at UC Berkeley, we believe in open source. And the reason for that is that the communities that we're describing are strengthened by that. So, for example, if you're using R instead of Stata or SPSS, Stata and SPSS, well, SPSS is proprietary. And so we really like to strengthen our communities. In R, there's so many different statistical packages that are sort of ready to go. So I think that that is definitely a compelling argument as well. But I think that especially if you're starting to go down this road in terms of cost, I would definitely look at proprietary software costs versus open source software that doesn't have that relative cost. I think that that's another piece.
That's definitely a really important piece. Yeah, thanks, Claudia.
Sure.
So would you say that Jupyter is just basically kind of like the social science version of MATLAB?
Oh, that's an interesting way to put it, but I think actually that might be sort of narrowing down Jupyter Notebooks too much. If people are familiar with gravitational waves, this like probably one of the biggest discoveries that have been made in physics since probably Einstein. They discovered that gravity has waves or something. I'm not entirely across it myself, but you can go online and see the Jupyter Notebook in which that discovery was made. And so they're not just a social science thing, they're really all across departments on campus.
Right. In fact, I mean, it originated from the sciences.
Mm.
Claudia, earlier you were talking about using qualitative methods to kind of create the data set that you're then using. And that kind of brings up the larger question of qualitative versus quantitative when we are talking about data science. So let's say that I'm just a novice when it comes to Python or something like that. And I'd like to know if I could use Python as an example or other packages, but we'll use Python for any kind of data in social sciences, whether it's quantitative or qualitative or mixed.
Python specifically is not the best language for parsing qualitative data at this time. It really depends on how you consider it. I mean, of course, Geoff is giving us an example of a type of qualitative data, text, that then becomes used in a quantifiable kind of way through computational text analysis. But if what you mean is more traditionally qualitative methods where we have qualitative data analysis tools. One tool that we really prefer here at the D Lab is MaxQDA, which is a proprietary piece of software, but currently there's not an open source package that has been updated. There is one in Python that is currently out of date and not really being maintained. There's not a very strong community around it. Obviously, it's sort of my ideal would be if there was one in Python, and hopefully somebody out there is going to create that or continue to strengthen that. But MaxQDA is a very powerful tool that allows you to thematically code qualitative data so that then you can interrogate from content analysis, which is different than computational text analysis. So when you're doing discourse analysis or content analysis of qualitative data, you're not really worried as much about the quantity of each thing. You may say this term, for example, I work in educational language policy, and so I care about bilingual education, I care about restrictive language policies, and so I may actually look to find it within MaxQDA, similar to computational text analysis, how many instances of bilingual as a term comes up in my corpus, which is a broad array of different pieces of data, which is interviews, observational data, documents. And so I want to see how many times the term bilingual is coming up in one specific interview. It happens to be coming up much more. So this person is very interested in bilingual education, is really invested and advocates for bilingual education. So what are the proximal terms around that, similar to computational text analysis? But really, the terms here are like close reading versus distant reading. So as a qualitative researcher, you're much more focused on the close reading, and these tools help you hone in on where to do the close reading, whereas in computational text analysis, you're really using text as data, and you're really using statistical methods to think about this data. And within qualitative methods, you're actually using ethnographic, grounded theory. These are different approaches and methods to think about qualitative data. However, some similarities do arise, such as reproducibility. We in MaxQDA, for example, or Deduce, or previously in Vivo or Atlas TI, there's a lot of different packages for qualitative data analysis. You do document your interpretive steps, and you can collaborate. And so it's moving towards the same kind of practices in terms of like being able to communicate with other researchers and to build off the knowledge. But I would have to say that although Python is an incredibly powerful tool, it wouldn't be specifically used for labeling data.
Yeah, labeling the data yourself is not a Python thing.
But in the back end, XML is what is being employed, and so markup language, and so that's ultimately what it is that we're doing. Is when we're labeling data, we're actually marking certain parts of the text and flagging it to be, so for example, in my example, bilingual education. Oh, okay, so you're flagging that term is coming up, and so therefore you can call it up in very fast and very flexible kinds of ways.
Yeah.
And you may have mentioned this, and I'm sorry if I missed it when you were talking about open source, but is Jupyter free?
Absolutely. It is 100% free, and it will remain 100% free because I know that the people who work on it are entirely devoted to this.
And not only is the application itself free, but I think what we're trying to emphasize here is that there's a body of these notebooks that has been developed in every, almost every area you can imagine. So the folks out there who come from different disciplines have different research problems, have different curiosities. There's Jupyter notebooks that are being developed in all these different areas, and so therefore you can call up one of these notebooks and actually look to see, as Geoff was mentioning, how the process of this research actually was conducted. You could see the code. You could actually copy and paste code.
Mm-hmm.
You could clone the entire notebook. And so it's really a very powerful and versatile way to do programming within that environment.
Now, I know we're here in part to promote the Sage Campus course, but are there any books or anything that I can use for kind of self-practice to either get ready for the course or after the course or during the course or independent of the course that you would recommend?
That's a great question. So, I mean, part of just going back to something that Claudia mentioned, I think towards the beginning of the webinar, was that this really is a zero, sort of like zero prior experience assumed in this course. So no barrier to entry. So you don't really need to know anything other than that you're a social science inclined person and that you care about these sorts of questions. There's really no reason to try and pick up R or Python beforehand. That's definitely something that we teach you about in this intro course.
Right, and I think, like, importantly, it's funny because there's the Data 8 open textbook,
Mm-hmm.
and I think, like, there's a lot of resources, and we provide, in fact, one of the things that you really get from this course is the wealth of different resources that exist. And so to just think of one specific book, I think part of what we're arguing is that there's these different communities of practice, and then once you start to get your sort of feet wet and sort of wade in the water and try things out, then you can kind of go back and forth within this community as a sort of a different model than a book where you're kind of going through this linear process of like kind of reading through and then, okay, I finished this book and now I'm going to put what I learned into practice. It's like really kind of a much more dialogic or kind of practice-oriented approach where it's like we'll teach you, we'll give you a little video snippet of a concept, and then we'll help you, practice, through different tools and different things that are available out there that may be, for example, Qualtrics, which is a basic level of Qualtrics is free, and then if you want to have more respondents, etc., there's a fee. But so you'll get to know a little bit more about this survey application called Qualtrics, which is incredibly powerful. And so we'll tell you about it. You'll have a little something to read about it, and then we'll show you how to use it and its power. And so that's kind of how we iterate through is basically through that process.
Yeah.
So that's all we have time for today, and I want to thank you, the audience, for joining us, and I want to give a special thanks to our guests, Claudia Von Pacano and Geoff Bacon. Again, their Sage Campus online course, Introduction to Data Science for Social Scientists, starts May 14th, and as you can see on the slide, registrants for this webinar can enroll a discount, just $269 by using the promo code SCDIS10. In the coming weeks, expect an email that includes a link to view the archived webinar and slides, as well as answers to some of the questions we did not get to today. And Vernon Gale supplied some YouTube links in the questions that we'll probably include also. And this will be hosted on the Sage Campus blog at campus.sagepub.com and also on the site that I'm community manager for, which is methodspace.com. And don't forget, we have more Sage Campus webinars coming. The next is on June 1st when Andy Kirk, a data visualization expert and course instructor on Introduction to Data Visualization, will share the do's and don'ts of visualization. And if you'd like to join that webinar, email Lucy Golding at Lucy, Lucy.Golding, Golding, at sagepub.co.uk, and we'll make sure you are included in the invite list. And once again, thank you so very much to all that made this a wonderful webinar, and thank you again. Bye.
Bye-bye.
See you in the course.